Hey, it's Kley. Welcome to another video. This is going to be an overview of what I'm going to call off-board wiring. So a lot of the times when you're building guitar pedals, you may have a kit, and the kit will include everything: the enclosure, the jacks, the foot switches, the PCB, all the components that go on the PCB, etc. But other times, if you get a little more advanced, you may start doing some of this yourself, where you're buying PCBs and you're populating it yourself, but then you're also supplying your own off-board. So off-board is all of the stuff you see on the screen here that doesn't include the stuff on the PCB. And so this is what I'm going to refer to as kind of a general overview understanding of how off-board wiring works in a pedal. And basically what this allows for is all the switching and all of the kind of, I'm going to call it administrative control of how the pedal operates to work correctly. So this is a kind of a generic diagram, and there are a lot of little variations on how different people do this. I'm going to try to touch on some of those things, but give you some of my tips as we look through this diagram. So to start off with, let's talk about our input and output jacks. Now, these are 1/4-inch jacks. They accept a 1/4-inch guitar cable. Now, with jacks, this one over here, this would be our output jack, and this is what I'm going to call a typical or a standard mono 1/4-inch jack. As you can see, it just has 2 terminals, a tip and a sleeve. And you can see here that, see how there are these 2 little brown, I think they're like some kind of plastic separators. And then you've got this part here that reaches out. And if you actually hold one of these in your hands, you can see how this part here that is connected to this ring here labeled as the tip. Okay, and whereas this other one is, if you were looking at it from a face on, you would see that it is actually connected to this part of the jack, which is again the sleeve. And if you have ever held a guitar cable, if we look at this one here as an example, you can see that you've got this little end point here with this kind of dip in it, and then there's this black separator, and there's this sleeve here, the shaft. And that corresponds with what we see here. This little notch fits into the end here of the tip, and then the sleeve touches this part here, and that is how the cable transmits its signal. The hot or the positive end that your guitar signal, the positive end is being transmitted on, contacts here at the tip and exits through the tip terminal. And then the ground portion is on the shaft, and that connects here to the sleeve output terminal, and that is how you ground it. In order for electronics to flow, you have to have both the positive connected to all the positive points for the signal to flow, and then all of the negative points need to be connected via ground. Now, on the input, though, we typically use a special stereo jack. And this is kind of a unique type of jack, and what happens here is you've got 3 connections. We've got our tip, we've got a middle connection, which is our ring, and then we've got our sleeve. And basically, if you can see how this one has 2 brown plastic points separating 2 terminals, this one has 3, 1, 2, 3. And the middle one is added, that's the ring. What's basically happening here is when there is nothing plugged in, the ring is isolated and elevated. But then when you plug your guitar jack in, it now connects this ring to the sleeve, the ground point. And so what this typically means, as you can see here, we've got our battery here. The positive portion is connected over here to our battery supply, or our power supply jack, but the negative point is connected to the ring. So what this means when you wire it up like this is your battery, this ground connection, does not connect to the rest of the ground and the rest of the circuit until you plug your jack in. So that basically helps you so that you aren't constantly bleeding signal out of your battery and running them dry when you're not using your pedal. So if you've ever heard, if you pull out the cable of the input jack, that will shut off the battery. That's basically why this happens, because when you plug the battery in, this negative ring is connected to the ground point here on the sleeve. So it's a pretty handy little trick. And now on this diagram, they're using this star ground point on the input jack. That certainly is one way to do it. I've also seen people that have a ground point on their PCB board, or there are a lot of different ways you can do it, and they all kind of have their pros and cons, and I'm not going to go into that right now. But just know that all these ground points are connecting here at this star ground here, which is a pretty convenient way to do it. Next, let's go to our we talked about our battery. Let's talk about our 9-volt plug. The 9-volt plug is typically, I would actually have this rotated 90 degrees. You've got this connection here, which is longer, and it's got this metal part that's a little more flat to see. That's your negative ground. And then you've got 2 positive terminals. The top here is your 9 volts that is coming in through this power supply, through your power supply from the wall. So that's getting 120 volts, or I'm sorry, that's getting 9 volts in from your power supply. And then this other terminal here accepts the 9 volts from your battery. So if you don't have anything connected, it will use the battery. But if you do have something connected, it'll use this top terminal here. And then that sends 9 volts out here to your circuit. There's a second output here, which is going to your LED indicator. So there would be a resistor here, and that would help to make sure that our LED doesn't burn out. But you do need the 9 volts to power that LED. And then that gets us to our switch. I've got a whole other video on my channel on how switching works, so I'm not going to go super in detail on that. But I will kind of cover it somewhat briefly here and talk about some of the tips and tricks that's happening. So the signal comes in from the tip of our input jack. Then in the off position, it's allowed to go down and is true bypassed and goes out. Also in that position, these 2 connection points are jumpered. The middle one here is our ground, and the bottom one actually is jumpered to the input of the circuit. And this will help us to avoid any kind of popping or any noises that would be generated. So the input of our circuit is grounded, and there's no residual voltage that's just kind of sitting unoccupied on the input of the circuit. Then when you flip the foot switch, all these 3 connections go up. The input here comes to the input of the circuit. The LED now has a path to ground. Then the output of the circuit goes to the output jack. And then the only other points that I want to make is just about how you connect all this up. A lot of the times you are wiring all this up with your enclosure. Now, the thing you need to realize is that what we talked about here, this ground point, is the sleeve. Well, this part of the sleeve is going to be screwed onto the enclosure, which basically means that the enclosure is grounded, which is good because it helps provide you some shielding. It basically makes a Faraday cage. Now, it is possible you can get some grounded jacks, but in this situation, you actually want that ground connection. But also realize that anywhere on your enclosure is basically grounded. So if you have parts of your circuit, you've got wires that are going off in different places that could potentially contact the enclosure, that will short them and ground out your signal, and that's not good. So you may need to use some electrical tape, or just be mindful of the way you're mounting all of your components so that you don't have anything touching inadvertently to the enclosure. Next, it's a good idea to just be mindful of how you're mounting all these things, specifically your input-output jacks and your foot switch. You probably want to use that you're going to have a screw that's going to tighten down to provide the pressure to keep it in place. But you also really want to use washers on both sides, both the inside and the outside. That's going to help distribute some of that pressure so that over time they don't become loose. I know in my early days I didn't always have the right washer, or I was too lazy to use one, and sure enough, maybe a month or 2 or 3 or 5 later, that input jack is going to start rattling, or that foot switch is going to start rattling. That's because it's come loose over time. So using washers on both sides is a good way to help reduce that from happening. It still may happen at some point, but it'll reduce the chances of that happening. And even with your foot switch, a lot of times they may have different types of washers. You can get a toothed washer, which can help to bite into the inside of the metal. And then on the outside, you may have like a little plastic washer. And the plastic washer will help kind of sponge up some of that pressure even further and almost creates like a pressure fit to hold things in place. You can even take it a step further and use like Loctite or like nail polish in the threads of your screw to help hold it in place even further, but I wouldn't say that's necessarily required. Overall, that's kind of my breakdown of how this whole offboard wiring works. If you have any questions, please let me know down in the comments section. If there's any other instructional videos you'd like to have answered, please leave that question down below and I'll see if I can get to it. And I hope you guys enjoyed this, found it informative. Thanks. Have a good day. Bye.